So Michael Fitzsimmons has lived and worked in Ontario, Yukon Territories, Alberta, and Saskatchewan. He has degrees from the Faculty of Environmental Studies at the University of Waterloo and the College of Agriculture at the University of Saskatchewan. Michael's expertise is in ecosystem science. His work has provided him with insights about a broad range of Saskatchewan ecosystems, including grasslands and durum fields near the Montana border, in forests and lakes in northern Saskatchewan, and much of the lands and waters in between. Over the past 35 years, Michael has worked in fields such as park management, organic agriculture, forest conservation, range management, and water protection. And after 15 years living in the Val-Marie and Duck Lake areas, he recently moved to Saskatchewan and continues to work towards the protection of nature and the sustainable uses of land in Saskatchewan. He's going to be speaking today about the ecological benefits of forests and the impacts of their loss in the southern Boreal region. So good to see you, Michael, and just take it away.
Okay, thank you. You can hear me okay?
We can.
Okay, so I'm going to try and share my screen. I'm not very good at this sometimes, but here goes. So can you see my first slide there?
Yes.
Okay, so I'm just gonna, if you don't mind, maybe can I turn my camera off? Can I have my camera off and the slides on? Okay. So thanks for that introduction, Lyle. And it's a pleasure to be able to talk with all of you today. As Lyle mentioned, the talk is about the benefits of forests and the impacts of their loss. So this is a map of the ecoregions of Saskatchewan. And I'm going to be talking about the Boreal transition area. So I'm not sure, you can't see my mouse, can you?
Yeah, with your little
Oh, you can see it?
going. Yeah.
Okay. So anyways, this is the Boreal transition region here. It's sandwiched between the aspen parkland, which is this reddish brown color, and the lighter and brighter greens up above the mid-boreal region. And so it's a transition zone between the dominantly evergreen forests of the Boreal and the dominantly aspen and mixed with prairie in the aspen parkland. It occurs where precipitation just exceeds evapotranspiration. That's what trees need. As I mentioned, it's because a transition region, it has both broadleaf and conifer trees. So the inhabitants historically, Treaty 4 and Treaty 6 territories are within this region. It's a homeland of the Métis, and people lived off the wild biota, including the fish, wildlife, and berries for food, and they used the trees for heat and shelter. And Indigenous people continue to utilize this natural productivity, but their access has been much reduced by land privatization. So the Boreal transition has many important functions, ecological functions, and I'd like to talk about a few of them. The first, in terms of the hydrological cycle, forests act as a sponge that absorbs moisture. So when it rains, the water is absorbed into the forest and the forest floor, and it's released slowly. So a good way to think about this is, you know, if there was a mountainside and it was covered with trees and it rained a lot, the forest would absorb that water and just slowly release it to the streams. Whereas if the mountainside just got logged off and there was no trees there, and you had the same big rain, all that water would just gush into the streams right away. And that's what happened with some of those big floods like in Merritt, BC. A lot of those areas had been heavily logged. And so when the big rains came, those atmospheric rivers came, the land couldn't hold all that water and it ran off. So outside the mountains and flatter landscapes, it's a bit different, but those forests still maintain that same function. They absorb water, they release it through evapotranspiration. They transpire whenever they're photosynthesizing, they're transpiring water. And that water vapor condenses into clouds and rains somewhere else. So other functions that the forest plays, one would be to do with the energy flows. So if that tree wasn't there in that first diagram, the sun's energy would just either reflect off as light, or it would be absorbed by bare soil and rocks and during the day and radiated back to the atmosphere and space at night. So it's a very direct, simple system. Whereas when you have a living ecosystem, it captures that solar energy and diverts it into different pathways. And the more a diverse set of pathways that you have, the more resilient the ecosystem is. So, you know, a tree can be eaten by an insect. The tree can directly drop its leaves to the decomposers. There's several different pathways, and an example of this might be, say, aspen trees. Aspen trees could be eaten by a wide variety of species, by moose or elk, by snowshoe hares, by tent caterpillars, by ruffed grouse. There's a whole bunch of different pathways that energy can go after it's stored by the tree. And eventually, yes, it does go back into the decomposition realm, and that heat is eventually released, but the living ecosystem slows down that release of heat back. And that's kind of a fundamental process of living ecosystems. They start slowing things down. And if we look at carbon instead of energy, so forests store carbon. They take carbon dioxide out of the air and create these simple sugars that contain carbon in them. So they're removing carbon from the atmosphere. I'm not sure if you can see there's some small green arrows going down. That's taking carbon dioxide out of the atmosphere and storing it in the terrestrial ecosystem. And with decomposition, those little orange arrows go back up. So an intact forest ecosystem has these somewhat in imbalance, but when you clear or burn the forest, you get pretty much it's all releases of carbon back into the atmosphere. And if you can regenerate the forest, that happens after, say, a wildfire, then young forests actually absorb a lot of carbon from the atmosphere. But if that land is diverted into farmland, pasture, or cropland, then that carbon that was in the forest is permanently left in the atmosphere. So globally, about 1/3 of the increase in carbon dioxide in the atmosphere since the Industrial Revolution was caused by deforestation, or the conversion of forests to non-forest ecosystems, such as cultivated fields, pastures, roads, settlements. And all of those things decrease the total vegetation biomass in the system. And destruction of forests continues to drive climate breakdown, whereas gains in forest areas could slow climate change. So the boreal transition is an important ecosystem that has many valuable functions. It's there's a large number of wildlife species that are resident in the region all year long: moose, snowshoe hare, variety of other species. But there's a real explosion in the species resident in the area during spring and summer. Species such as thrushes, sparrows, and warblers escape northern winters by migrating south, but then they travel north to take advantage of the seasonal abundance of insects and seeds. I'd like to talk briefly about one of these species. So this is the Connecticut Warbler. It's a migratory songbird that nests in open types of broadleaf and conifer forests. It's called the Connecticut Warbler, but it was first described in Connecticut, but it doesn't actually live there. It migrates, passes through there once in a while, but it actually is a Canadian bird for the most part. It arrives in the southern boreal forest in May, and it will nest in June, and the young of the year will fledge in July. And it fattens up before it leaves the boreal forest for migration in August. And here's a map of that distribution. So it's a little bit in the United States around Minnesota, but mostly it's all in Western Canada and through Ontario and a bit in Quebec. But it covers a region where there's lots of current agricultural activity, and it occurs in only a thin band. Although the boreal forest is much larger, this particular bird is only in that thin band of that boreal transition region in Saskatchewan. So the bird is seemingly less than impressive physically. It's less than 6 inches in length. It's only weighs about half an ounce, or about a tablespoon of sugar would weigh about half an ounce. It forages on the ground. It's not a big predator of big things or anything. And its song is not particularly loud. I'm going to try and play that song. I'm not sure if you can hear it. Wait, here comes another one. So, but where the bird does show off its physical prowess is in migration. So the bird comes all the way from its wintering areas in southern Venezuela and northern Brazil, travels across the Caribbean, sometimes flying for 48 hours nonstop, and then crosses the Midwest and some of the Great Plains to find its way into Canada in order to breed. So I don't know about you, but I can't do many things nonstop for 48 hours. So it is quite an impressive bird, and it's one of the species that we coexist with on the planet and that we should value. But it's in decline. Like many other birds, insects and birds are in decline, and one of the causes of the decline is the loss of breeding habitats. So this is the loss of breeding habitats. If you go into any local history book in that boreal transition region, and that's, as I said, Tisdale, Prince Albert, Meadow Lake, in that whole region, if you find their local history book in the library, you often see pictures like this. Giant logging operations during the early settlement period. This one, the text at the bottom says it was white poplar siding, and white poplar siding became known as a town called Villardville, because one of the settlers there was named Villard. So the post office was named Villardville. And you can see in the old picture that it's covered in trees and they're pulling out giant logs. And now if you look at that area on the satellite image, you can see it's mostly all been cleared for farmland. There's a few wet areas, creeks or something that the the forest has been maintained, but mostly it's all been converted to farmland. So this is a map based on a book called Forest Regions of Canada, written in 1959 by Stan Rowe. He eventually became a professor of plant ecology at the College of Agriculture in Saskatoon. And he went across Canada and mapped all the forest regions, the different types of forests that are in Canada. So this is a current Google Earth satellite image. And it shows where the southern edge of some of, or the sort of clear edges of the forest. So the south end of Prince Albert National Park, the Fort Alacorn Provincial Forest, the edges of the Pasqua Hills and the Porcupine Hills. And there's a really distinct line there. Whereas if you overlap this with Forest Regions of Canada, you can see that each one of these areas were well within the forest boundary. So the Fort Alacorn, what they call an island forest, for example, was not an island at the time. It was part of the contiguous boreal forest. And some areas like the southern edge of Prince Albert National Park were tens of miles away from the southern edge of the boreal forest. So I've zoomed into that area by this is the Sturgeon River that flows through the southwest part of Prince Albert National Park. So you can see to the east and north of the river, it's all natural forests, and to the south and west of the river, there's a real mixture of farmland and some forest patches. So Prince Albert National Park actually came from the Sturgeon Lake Forest Reserve, and it was set aside. It was set aside from agriculture. In the 1920s, there was a debate between different government departments about what the best use of the land was, and the Department of Interior argued that the best use of the land was for forests in this area. So they set aside some of this area. It wasn't set aside from forestry, it was set aside from agriculture. And that's the history of the Sturgeon Lake Forest Reserve. And so I want to zoom in. This is a community called Stump Lake, and you can see that the land is, you can see the quarter sections of the land, but there's kind of a diagonal line here, and I'll just zoom into that with some satellite images. So this was in 1985, the satellite image, and the satellite images in those days weren't as good. They didn't get as clear images, but you can see there's clearly forest. That diagonal line of forest cover is visible. And this is in 2012. So you can tell that they've started to whittle away at that diagonal section of forest. They've broken it off, fragmented it from the more contiguous larger block of forest. And if you go a few more years down the line, this is 2019, now they've cleared all of this off and just left very small patches. And that's one of the issues with deforestation, is it fragments what's remaining into smaller patches, and those smaller patches would be, say, too small for a bird like the Connecticut Warbler and lots of other birds to maintain a territory. So in addition to, wildlife impacts like that, the forest ends up releasing a lot of carbon into the atmosphere. So in that satellite image area, I did a study quite a few years ago measuring the total amount of organic carbon in the forest, vegetation and soils in natural forest sites in Prince Albert National Park, adjacent, like just a few hundreds of meters away in what's the Cookson provincial pasture that was cleared of trees, and also a nearby site that was cleared of trees, then cultivated. And you can see that the average amount of carbon on these sites was cut in half when it was converted from cultivation to pasture. So that carbon then is released to the atmosphere. The good thing about this, if we reverse this process, you can take that carbon back out of the atmosphere and store it in vegetation again. And if you think this isn't very likely or possible, the entire eastern deciduous forest of eastern North America was largely converted to farmland in, say, the 1800s at some point, and was regenerated, and now has a lot of forest area in that region. But unfortunately here it seems like deforestation is still in progress. This is a photo I took in 2019 near Choice Land. You can see here's the heavy equipment that's still actively knocking down trees in this site. So Lyle mentioned that, you know, I'm an ecosystem scientist, and I'm interested in how ecosystems function. So this is that same area where it's being converted from forest to agriculture. And you can see that they've already started a canola crop here. So the forest in the background is what I call auto-sustainable. It doesn't require any inputs, doesn't require any management by humans, but it just grows spontaneously. Whereas the farm field requires a lot of inputs, fertilizers, often herbicides and pesticides, particularly with canola. It's a very input intensive crop. So when you lose forests and it's converted to farmland, you have all those additional impacts of the carbon that is burned, the fossil fuels that are burned to create all those inputs. So I'm going to talk briefly about logging. Forestry companies often enter Saskatchewan briefly. They extract a bunch of trees and their profits, and they leave when they run out of trees that are big enough or find other more profitable places to operate. And this happened, the Prince Albert Lumber Company, that was a century ago. Parsons and Whittemore started the PA pulp mill, that was 50 years ago. Simpson Timber and Weyerhaeuser Canada left Prince Albert and Hudson Bay areas. Weyerhaeuser left Prince Albert, and Simpson Timber left the Hudson Bay area, you know, some 20 years ago. So there's a long history of this in Saskatchewan. And I think we have to recognize that companies are really about extracting profits. They have no long-term commitment. So it makes me leery to hear that Paper Excellence wants to come and open the Prince Albert pulp mill. So Paper Excellence operated Northern Pulp, a company in Nova Scotia that dumped millions of liters of toxic contamination into waters over decades and decades, waters used by Pictou Landing First Nation. And eventually the government had to shut them down. They refused to properly manage their liquid effluents, and the government had to shut them down. They were given a deadline, time to, you know, adjust their operations, and they wouldn't do it. So Paper Excellence has a billionaire owner from a family active in forestry projects causing tropical deforestation in Indonesia. So I'm not sure why we would want to do business with this company. But the government of Saskatchewan wants to grant Paper Excellence a license agreement that will let them take trees not only from the provincial forest to the north, where the old pulp mill used to get trees from, but also from private farmland. And this was likely to further drive deforestation on private lands and add more carbon to the atmosphere. And in the provincial forest itself, both the government and the companies, they want to try and compress the age class structure. They want to get rid of older trees and have more younger trees. And this is the age class structure of the forests around the Prince Albert area. You can see there's So this is the area in hectares of each age class. So trees between, say, 60 and 70, there's very few trees for some reason in that age class, whereas from 80 to 9-year-old trees, there's many trees. And it has to do with variations over time in logging rates and fire. You think 80 to 90 years ago, that was when there was a lot of settlement, escape settlement fires, burned into the forest, new stands were generated, and that's those 80 to 90-year-old stands. But it's very natural that you have a lot of variability in this age class structure. And the government and the forestry industry, they want to create this smooth curve, this theoretical curve, which often doesn't ever occur in nature, but they want to create that by lopping off all these areas with mature trees. And I think it's a strategy that's just going to send carbon back into the atmosphere because it's reducing the pool of terrestrial carbon. So I just want to throw in a few take-home messages. Forests have values essential to maintaining the life support system we all depend on, including storing carbon in trees, dissipating solar energy and delaying heat releases, absorbing and transpiring water, and supplying wildlife habitat. Second, the cumulative effects of small land clearing decisions by individual landowners result in large region-wide contributions to climate breakdown and other life-supporting ecosystem services, and deterioration of other life-supporting ecosystem services. Third, if you have land with standing trees, resist the temptation to further convert forest to cultivated land or pasture. Better yet, if you have marginal cultivated land or pasture land that was forested prior to settlement, consider planting trees. I hear that the government has 2 billion trees that they want to see planted across Canada. Fourth, forestry corporations have only one interest: short-term profits. They may need to stick around for a decade or two to reap the benefits of their capital investments in manufacturing equipment, but sooner or later they will likely cut and run. So we need to act to ensure governments look after public interests in forest lands. Fifth, we need to manage forests primarily as carbon reservoirs rather than just as places to extract resources from. Lastly, I hope that we can think about children and grandchildren. The only way that they will have an intact life support system decades from now is if we reduce our carbon emissions to the atmosphere, decrease our levels of material consumption, and shrink our collective environmental footprint by rewilding land.
Well, thank you very much, Michael.